Alrighty, hello again. Welcome to Chapter 8, where we will be testing validity for categorical logical arguments. Okay, we've learned how to diagram some of these things, how to graph propositions as they are. Now what we're going to do is we're going to take that graphing mechanism, if you will, and be able to test validity of arguments. And again, some people have had some confusion over this. When I talk about validity here, there's two senses of the word validity when you're talking about a logical argument, right? There's the general validity, and then there's just the purely logical validity. And I'll say a few words about the difference of that. Now, for an argument to be valid, right, and you can see this in the notes, all the premises must be true, and the logical structure must be good. What does that mean? That means that the conclusion necessarily follows from the premises. Now, an argument can be logically valid, or in other words, the structure of the argument could be good, such that the conclusion follows from the premises if the premises were true. But an argument can't be generally valid if the premises are false. So, again, it could be generally valid, the premises must be true, and the conclusion must necessarily follow from the premises. For it to be logically valid, or rather to say that the logical structure is good, the premises can be false, but the conclusion must follow from the premises. If it, and in some of those cases, we may assume that the premises are true or something like that. All right. So, okay. So testing validity isn't terribly difficult. Diagramming these things is kind of difficult, but there's a couple of notes that you really need to know, a couple of rules that you need to know. Remember, one of the rules that we saw in homework last week, hopefully, is that when you have two propositions, you always diagram the universal propositions first, right? Because that takes certain things out of the game. So that if there's particular propositions later, which we need to put the X's or the asterisks in, we know whether or not to put them on a border between two areas or within a whole area completely. So that's the first rule. The most important rule, though, when we're testing validity, okay, is to never diagram the conclusion. All right. So why is that? Why don't you diagram the conclusion, you may ask? Because in testing validity, what we want to see is if the conclusion necessarily follows from the premises. So, if you diagram the premises, right, the conclusion should already be there, just from diagramming the premises alone. It may make sense once we start getting some examples or so, but, right, so we know what a certain diagram would look like if, let's say, the proposition was all A or B. Let's do that real quick. So let's say A, B, C, and we want to say all A are B. Okay? And then we know, in order to diagram this proposition right here, what do? We shade the A's which are not B's. Okay? So we shade these A's. And I hope that you can see that I've shaded this area and this area right there. So essentially, let's say B is the conclusion. Alright? We don't want to diagram it along with the premises, but the diagram that results, right? So as I was saying, we don't want to, if this is our conclusion, we wouldn't want to diagram it with the premises, right? But by diagramming the premises, something that shows this, right, or that's representative of this statement in some way, it will just be apparent, will be there. That's what makes an argument valid, right? If it's not, then the argument is invalid. Okay? So let's go ahead and do a few actual examples here. And I'll go with the examples that I have down here, so I'll erase this real quick. Okay, so here we have the argument, all apples are fruits, all fruits are delicious, therefore all apples are delicious. Okay, so let's label this circle A, this circle F, and this the circle D. Okay, and now one quick note that somebody had brought up during the week. The text may say to make this circle your major term, this your minor term, this your middle term. As long as you label them, it doesn't necessarily matter. Like I said, I won't actually have you submit diagrams themselves to make, to see that, you're diagramming this exactly the way I have it. But you will need to know how to diagram. So on the homework and on subsequent assessments, when I test you on this, I'll give you an argument and I'll ask you to tell me whether it's valid or invalid. And in order to give me a proper answer, you're going to have to know how to diagram this, right? So let's go ahead and diagram this, right? All apples are fruits, okay? So let's write this up. All A are F. What's the next one? All F are D. Therefore, all A are D, right? That's our argument. So we're only going to diagram, remember, these two, the premises. So all A are F. Let's go ahead and eliminate all A's, which are not F's. Okay. The next one says all F are D, so let's go ahead and eliminate any F's which are not D's. Okay. And so that's what these two premises look like graphed. Now, what does the conclusion say? The conclusion says all A are D. Well, now let's look at our diagram here. Where do we have A's left that are in play? Well, these A's are out of the game as well as these. So this is the only area where we have A's left, right? Because we shaded the other A's out. Now, what can we say about the A's that are in here? Well, those A's are also are also F's and also D's. Okay? So, is it true on our diagram now that all of the A's that are represented are also D's? Well, yes, it is true, right? Because this is the area in which, this is the only area in which we have A's, and all of those A's are also D's, right? So this argument is valid, okay? And I hope that that's apparent to you, that you see why that is the case. So that's what I mean when I say we don't diagram the conclusion directly as it's stated, right? We don't actively diagram the conclusion, but by diagramming the premises, if the argument is valid, it should already be diagrammed for us in a way, okay? So, let's go on to another example here, right? In which we use some particular propositions. So I have the argument here, which states some A are B, some B are C, therefore some C are A. Okay, we're going to diagram this one right here. Let's go. A, B, C. Right? Okay. So, for the proposition some A are B, right? We need to put an X because it's a particular statement. All right? And we'll put the X right here on the line, right? And why on the line? Again, because it could be in either one of those areas, right? We're not sure, so we put it on the line to say it could be in one of those areas or the other area. So let's say some B are C. Okay, well, where do we have B's which are also C's? These two areas. Again, neither of them are shaded off. So let's go ahead and put the X there on the line. So now we look at what we have graphed, the premises, and we need to see if this conclusion definitely fits that picture, right? Well, it says some C are A, and in order for, what would that, so if that was true, right, we would have an X in an area where there are C's and also A's, right? And you may say, well, you know, Professor Balaver, we have halves right here in the central area, okay, two halves of X's in there, so then it must be valid, right? Wrong. That is not true. In order for a particular statement to be true, or a particular conclusion to be true, an X must be completely enclosed in an area, or it must be definitive, right? That that thing is shown. Okay, so if we see here some A or B, remember we were kind of hedging our bets, but that A that is a B could be up here. It's not necessarily the case that it is there. Likewise, with the some B that are C, it may not be the case that it's in this central area either. So we don't want to go ahead and say it because we're saying that the conclusion is necessarily true because we're not necessarily sure in this case where those A's and B's are, so to speak. So again, although we may be tempted to call this argument valid because there's something, namely half of an X, in an area that shows A's that are C's, this, however, is not enough for logical validity. So a whole X must be contained in an area for this to be valid. Half doesn't cut the mustard. All right? So let's look at another example. I'll erase this. Okay, so in this example we have no A or B, some A are not C, therefore some A are not B. A, B, and C. Okay? And so in this argument, right, I'll actually also erase this so it's not confusing at all. So in this argument, right, we have a universal statement and a particular statement. So we will diagram the universal statement first. Now which one is that? That is the first one, no A or B. So we shade here. And to show that no A or B, we have to find where are the A's that are also B's in these two regions right here. So we shade them out. We take them out of the game. Okay? Now, premise 2 states that some A are not C. Right? So we need to find the A's that are not C's. Well, you know, remember, normally, right, the A's that are not C's are in these two areas. So if this was a blank diagram, we would put it on the line. But remember that the first premise has essentially eliminated this area. Therefore, we put our x wholly in this area, which is the only area now where we have a's which are not c's, right? So now let's look at the conclusion to test the validity of this argument. So the conclusion says some A are not B. Now can we say definitively, right, from our diagram that there exists an A which is not a B? Well, yes we can, right? Because look, there's a whole X here that is definitely an A which is not a B. Right? So this argument is valid. Alright? And so as you can see, here's the conclusion. We can see that conclusion diagrammed for us just by diagramming the premises. And therefore this is valid. We're going to do one more example here. Let's call them again A, B, and C. And so now this argument says no C are A, no B are C, therefore some B are A. So let's go ahead and diagram this, right? The first premise, now again, both of our premises are universal, so it doesn't matter which one we go with first. Let's go with the first one. No C are A. Where do we have C's that are A's? Why, in these two regions here. So let's go ahead and shade them out. And remember, we're shading those two regions because the premise states, right, that there are no C's that are A's, right? So any C's that are A's, we have to take them out because those don't exist. So likely with the next one, no B's or C's, well, this is the only area left that is a B and is also a C, so we will go ahead and shade that area out. So now let's look at our conclusion. Some B are A. Well, what are we looking for to be diagrammed? We're looking for an X somewhere, but we don't even have an X. So this is a good tip, right? An argument that has two universal premises can never lead to a particular conclusion. Likewise, an argument with two particular premises can never lead to a universal conclusion, right? And why is that? Well, because if you have two universal premises, as we do here, there's no way that you're going to have an X diagram somewhere. Okay? Likewise, right, if you have only X's, you won't have areas shaded out. You won't be taking anything out of the equation, which is what you need for universal premises. Right? So if you have two universal premises, you can only have a universal conclusion for it to even be considered right. Now that doesn't necessarily mean, right, don't take this the wrong way, this doesn't mean that if you have two universal premises, it's automatically going to be a valid argument. No. There's still some work that needs to be done there. But if you have two universal premises and a particular conclusion, there's no way that will be valid. Likewise, if you have two particular conclusions and a universal, two particular premises and a universal conclusion, there's no way that will be valid either. All right? So that's all I have for you for this installment. Go ahead and try to do the homework. Again, if you are having a hard time diagramming, please let me know, because you really won't be able to do this stuff if you can't do the stuff that was from Chapter 7. which was just the diagramming there. So if you're having a hard time, let me know. I'll try to help you out. We can possibly meet up or something along those lines, and we can get you on the right track. But if you can't diagram, then you really will not be able to assess validity. So it's very important that you're up to speed on the stuff that we just did in the last lesson plan, last learning module rather. So let's go ahead. We're going to wrap this up. If you have any questions, please email me. And good luck on your homework and quiz coming up.